Welcome to the viewers. Now we discuss an important question: why Jacobian of the canonical transformation is unity. Now we have to solve these questions. At first, we are taking for the canonical transform from QP to QP, capital QP, and is given by Poisson bracket of Qi Qj, that will be 0, Poisson bracket of Pi Pj under the transformation for Qp, and here Q is the coordinates and P is the momenta, we know. Here also Poisson bracket, same notation we use, that will also be 0. And third one, and the components Qi Pj for Qp, that is delta Ij, as usual meaning. Now for one dimensional space, the Poisson bracket is Poisson bracket Qp for Qp is essentially equal to Jacobian determinant. Therefore, Poisson bracket of Qp del Q, by definition, del Q del P minus del Q del P del Q, that will be Jacobian of Qp under Qp. So here we taking it equation number 1. Now we consider the quantity P dq minus capital P dq. It is our requirement. It will be P dq minus capital P into that Q is the function of small q and small p. Small q is the coordinate and small p is the momenta. So by the property of differential equation, del q total derivative, that will be several variable for del q plus del q into dq and del q del p into dp. Here it will be del q into dq plus del p into dp. We break this bracket, minus p del q into dq minus p del q del p dp. So it will be taking common p del q into dq minus p del q dp del p into dp, taking it equation number 2, which makes perfect differential if del p of p minus p del q dq is equal to del q of minus p del q del p, that is del p is 1, del p del q is equal to minus p del to q del p del q minus p del to q del p del q del p minus del p del q del p, that is these two terms cancel by the property of partial derivative, because del to q del p del q is equals to del to p del q del p. So we have del q del p minus del q del p del q, that will be 1, that is Poisson bracket of qp is equal to 1, and which is a perfect differential, and therefore we can prove it already. This will be equal to the Jacobian transform, that is J of qp of del of qp, that is Jacobian of eta 1. So we can prove this Jacobian of this equals to 1, since they are same in the Poisson bracket as well as property of Jacobian. If we breaking this property of Jacobian determinant, we can already found it here, that's Jacobian of qp and Jacobian of qp, that will be determinant of del q and del q del p and del p del q and del p del small p. If we break this, we can find del q del p minus del p and del p del q. Already got this result. This will be 1. Now we end our discussion today. If you like this video, like it, share it, and don't forget to subscribe the channel. Thanks for watching.